Hello Worthington students, here to review for the MCA. This lesson is all about the midpoint and distance formulas. So we're going to jump right in. We're going to start with the midpoint formula, talk about what it's doing and how to find it. So a midpoint of some segment is going to be found by using this formula, x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. So what is it finding? What is it finding? It is finding an ordered pair. Some point x, comma, y. It is finding a point for you. And if we think about it, well, what are we doing when we add numbers and divide by 2? Well, we're finding an average. Adding numbers dividing by 2, we're finding an average. So what we do is we're finding a middle. We're finding the average of the x's and the average of the y's, and that's going to be our midpoint. So that's a good way to keep midpoint formula in mind, is to use the idea of the average of the x's and the average of the y's. That's where your midpoint is. So let's give it a try. So if we have some segment whose endpoints are at P, which is at negative 8, 3, and Q, which is at negative 2, 7, if we're asked to find its midpoint, well, we need to find the average of the x and the average of the y's. So let's give that a try. Midpoint is found by adding the x's, which would be negative 8 and negative 2, and dividing by 2. We're going to find that average. Then the average of the y's, which would be 3 and 7, and divide by 2. So our midpoint, this ordered pair that we're finding, is going to be at, well, negative 8 and negative 2 make negative 10 over 2, and 3 and 7 make positive 10 over 2. So the midpoint for this segment happens to be at negative 5, 5. The pair, the ordered pair, negative 5, 5, that point. All right, that was midpoint formula. I think it's pretty nice, pretty quick. Hopefully that goes well for you. What might be tricky is if they give you a problem that's a little bit different. And this one says M is the midpoint of segment XY. We know where X is and we know what the midpoint is. Find the coordinates of Y. So this time, are they asking me to find midpoint? The answer is no. They are giving me one endpoint and the other endpoint is unknown. It's at some X and some Y. I don't know what that is. But I do know the midpoint. So what I can do is still use that midpoint formula. I know my midpoint, which is 6, 1, is going to be found by adding my x's. 2 plus x, 2 plus x divided by 2, and then the y's. 7 plus y divided by 2. So what I know is that when I use the midpoint formula, when I take the x's x value and the y's x value, and I average, and then I find the average of the y's, my answer should be 6, 1. Well, how do I figure out where that point is? Let's split it up. I know x is going to be at 2 plus x over 2, and I know 1 is going to be at 7 plus y over 2. I know that when the average of the x is found, it's going to give me 6, and the average of the y's is going to give me 1. So that's what I need to simplify here. And to do that, we're going to use proportions. So we're going to cross multiply. 6 times 2 is 12, which is going to equal 1 times 2 plus x, which is 2 plus x. Solve for x, and we get x equals 10. Same idea for the y's. Putting this over 1, cross multiply. We get 2 equals 7 plus y, subtract 7. Y is at negative 5. That means the other endpoint is at 10, negative 5. And because they gave us one endpoint and a midpoint, we were able to use that midpoint formula to solve a different type of question. So we can actually find the midpoint, which is pretty straightforward, or we can find another endpoint when given the midpoint. So that's midpoint formula. Let's try distance formula. The distance formula between 2 points A and B are the points in a coordinate plane where the distance, the length from A to B, is going to be found by taking x2 minus x1 squared plus y2 minus y1 squared. So we're finding the difference in the x's squared and the difference in the y's squared, adding them, and then square rooting to find our length. That is the distance formula. We can use this for any 2 points to find the length between them. Okay, Let's go ahead and give it a try. This example says find the length of AB and the length of CD, and to determine are these two segments congruent, meaning are they of equal lengths. So what we can do first is start with A and B. First, when I'm starting with A and B, it's probably going to be helpful to figure out where is A and B. A happens to be at 1, 2, and B is at 1, 2, 3, 4, 1, 2, 3, 4, 4, 4. So we have our point 1, 2, and 4, 4. So we're going to use our distance formula. If you don't remember, distance is x2 minus x1 squared plus y2 minus y1 squared. So I'm going to plug this in. A is my first point, so I'm going to call this x1 and y1. B is going to be at x2 and y2. The 1s and 2s simply tell you point 1 and point 2. They don't actually do anything. We're not multiplying by anything. It's just telling me this is for point 1, this is for point 2. So if we plug that into the distance formula, the length from A to B, that distance is going to be the square root of x2 minus x1. So let's find the difference in our x's. So we're going to take 4 minus 1 squared plus the difference in the y squared, 4 minus 2 squared. Okay, now all we have to do is simplify. So if we remember our order of operations, the first thing we should do in simplifying is parentheses. So 4 minus 1 is 3 squared plus 4 minus 2, which is 2 squared. Now we simplified inside of our parentheses. Our next set of our next order of operations is to use our exponents. So that's what we're going to do. 3 squared is 9 plus 2 squared, which is 4. And then now we need to simplify underneath the radical before we can square root. So A to B equals square root of 9 plus 4, which is 13. Now, I'm going to leave that as an exact number. You could find the decimal approximation with your calculator if you want, but I'm going to leave it as root 13 for now. So I found the length of AB using the distance formula to be root 13. Now, let's use this same formula, same ideas, same concept, to find the length of CD. So, first step, let's identify where's C and where's D. C happens to be at negative, because I'm going left, 1, 2, 3, 4, negative 4, 0, no up and down. And D is at, let's see, left 1, down 1, 2, 3, so we'd be at negative 1, negative 3. Remember how to find your points on the coordinate plane. So, let's go ahead and use that distance formula. The length of CD equals the square root of the difference in the x's. Let's remember, this is the first point, so I'm going to call it x1 and y1. This is my second point. I'm going to call it x2 and y2. So I'm going to find the difference in my x's. I'm going to take negative 1 minus negative 4. Yes, I am subtracting a negative squared plus negative 3 minus 0 squared. Now, why was it important to make sure that I noted that we are subtracting a negative? Because that could really change the problem. Because subtracting a negative turns into addition. So when I go to simplify inside of my parentheses, I actually have negative 1 and positive 4. Well, the positive 4 is pulling harder by 3, so I'm really left with a positive 3 inside the parentheses. That's being squared. Instead of that negative 5, it was never negative 5. You had to make sure that you subtracted a negative. And then we're adding that to negative 3 and 0, which is simply negative 3, still in parentheses, squared. And then now we're actually going to do our squaring. So the length from C to D is going to equal the square root of 3 squared, which is 9, plus a negative squared is positive. As long as that was in that parentheses, which it should be, that negative squared is positive and 3 squared is 9. So the length from C to D equals the square root of 18. And again, I'm going to stop there. You can find the decimal approximation if you want, but if we notice, this one was root 18, this one was root 13. Are those identical? Are they congruent? Are they of the same length? The answer is no. These two segments are not congruent. they do not have the same length. And we use the distance formula to prove that. So, that's all I have on midpoint and distance formulas. I encourage you to remember, especially with the distance formula, that if you need to subtract a negative, you actually subtract the negative. Midpoint formula, don't forget you're finding your averages. Add the x's and divide by 2, and then add the y's and divide by 2. So midpoints are all about those averages. Distance formula is about the difference squared. So, good luck on your formulas.